Hello. Hey guys.
Oh, hello.
So if you saw the email I sent out, this week we have quite a lot to cover. We have a bunch of stuff to do. So I'm likely gonna have to extend class over 40 minutes to like somewhere around an hour. Because there's like a ton of stuff I have to go over. And I want to give you guys enough time to do the problems as well. But if you need to leave at 40 minutes, then you can do so, because the recording is always going to be on YouTube later, and you can watch the rest of class afterwards, whenever you want. Okay? So just a heads up there. I'm going to be teaching for around 1 hour today, and then after that, we'll do the quizzes for around 10 minutes. So overall, it's going to be an hour and 10 minutes for class today. All right, so if you just came in, if you didn't see the email I sent out, today's class is going to be a little longer than 40 minutes because I have a ton of stuff to go over. So it's going to be around 1 hour instead. But if you need to leave early, you can leave. But so like, because the recording is going to be on YouTube later, so you can watch the rest of the class later on. All right. People are coming in. So this is actually our second to last class, I think. Like I project that this will be our second to last class, and this will be our last geometry class. All right. And next week we're going to do counting and probability. All right. So including this week, we have 2 more weeks left. So here, let me share my screen here. So today is week 11 for Prealgebra. As you can see on the screen there, we're going to be going over quadrilaterals, all about quadrilaterals, okay? I'm going to wait just a moment for people to come in, then I'll get started. All right, so let's get started. Before we start, actually, if you just came in, just another heads up that this week's class is going to be 1 hour long. It's going to be longer than 40 minutes. But if you will need to leave at 40 minutes, then you can do so and watch the recording later. And then at the end of class, we're always going to do a quizzes as well. So if you want to participate in the quizzes, you have to wait the whole 1 hour. Okay? So the topics for today are quadrilaterals, obviously, and then we have what we call the quadrilateral family tree. All right. So let's get started. So first of all, we have quadrilaterals. What are quadrilaterals to begin with? What are they? Quadrilateral is any four-sided polygon. Okay, any polygon with four sides. All right. And a key feature of any quadrilateral is that the sum of all its angles equals 360 degrees. All right, for any type of quadrilateral. That comes from, if you remember from the angles lesson, comes from the sum of the sides. The sum of the angles in an n-sided polygon is n times, it's like 180 times n minus 2. Okay, so that's the formula from the area from the angles lesson. So that's how you would get 360 for the sum of the angles in a quadrilateral. Okay, so let's name the parts of a quadrilateral. Let me just draw something in here. Right, that has four sides. It's a quadrilateral. So we have some vocabulary to go over. We have these corners of a quadrilateral. What are these called? We call these vertices. Whenever I say a vertex or a vertices, I'm referring to the points in the quadrilateral on the corners. Okay. We have another new word that we use especially for quadrilaterals, and it's called a diagonal. What is a diagonal? A diagonal is a line that connects two opposite vertices in a quadrilateral. So if I take this vertice, the opposite vertice is here. If I connect those two vertices, we'll get a diagonal. So this is a diagonal in the quadrilateral. And I can draw another one like this. So in any quadrilateral, we have two diagonals. And those diagonals are lines that go through the insides of the quadrilateral. All right? We have a few other words here. One of them is opposite. Use the word opposite. Opposite refers to something on the other side of the quadrilateral. For example, these two sides I'm drawing here, are opposite sides. All right? And similarly, we have something called adjacent. Adjacent is the opposite of the word opposite. Adjacent means that these two things are next to each other. So what does this mean? Let me give you an example here. For example, this line with this side, they're touching, they're next to each other, so they're adjacent. Whenever I say these two sides are adjacent, then that means the sides are next to each other. And we can use the words opposite and adjacent, not just with the sides, we can use them to describe vertices too, as here, opposite vertices or adjacent vertices, and also with the angles in the quadrilateral. For example, this angle is adjacent to this angle, all right? So adjacent means next to, opposite means on the other side, okay? We have another new word coming in your way called bisect. What does bisect mean? Bisect means that something is cut in half. So for example, if I want to bisect a segment, I cut the segment in half. So if I drew a line like this and cut the segment in half, then I would say, oh, line L is bisecting segment AB. So to bisect means something is cutting AB in half, okay? And it's not just with segments, you could bisect an angle as well. So we have an angle here. Bisect means that, hey, this line cuts the angle in half. So bisect means to cut in half. As you can see here, there's the prefix bi, as in bicycle. Bicycle means two wheels. So bisect means cut into two equal parts, okay? And those are all the new words we need to know, but there are some old words that we should review as well. We have something called supplementary. If you remember from the angles lesson, supplementary means that two angles add up to 180 degrees. That's what supplementary means. Another useful word is congruent. Congruent means two things are equal. If I say two segments are congruent, then that means those two segments are the same length. All right? So those are basically the words we're going to refer to a lot in this lesson. So you're going to have to know these words to understand what I'm going to talk about. All right. So does anyone have any questions or need a refresher on what these words mean?
No.
All right. As you can see here, you may be wondering, what's this thingamajigger in the right side? That's actually what we call the quadrilateral family tree. Do you guys know what a family tree is? It's kind of like a tree with all your ancestors on it. For example, you could have your mom and your dad. It would go down to you. You would have your grandpa. It would kind of look like a tree, right? So we have a family tree for quadrilaterals. They're like one big family. So we have a great grandpa, and then we have a little kid down here. So these are all different types of quadrilaterals. All right. And why we call this a family tree and not just any like connections between quadrilaterals is that any quadrilateral on the family tree has all the traits of the quadrilaterals above it. So what this means is that, as you can see, I have a rectangle right here. That means a rectangle has the traits of what this shape is. It has the traits of what this shape is. It has the traits of what this shape is. It has the traits of what that shape is. Just like you have the traits of your mom and dad. You have the traits of all your grandparents and all your great-grandparents. So quadrilaterals on this chart, they have the traits of all the other quadrilaterals on top of it, okay? So that's what we call the quadrilateral family tree. And over the course of this class, we're going to be going over every single type of quadrilateral on this list, all right? So get ready for a lot of quadrilaterals. All right, so first one on our list, the trapezoid. So the trapezoid is the first quadrilateral. So as you can see on the top, this is not a trapezoid actually, this is just your general quadrilateral. Any kind of normal quadrilateral. Nothing special about it, just four sides, all right? So that's kind of like the great granddaddy. And then the first one down the line is a trapezoid. The trapezoid is right here on the family tree. All right, so that's the trapezoid. And what's unique about a trapezoid? A trapezoid is a quadrilateral with at least one pair of parallel sides. So in any trapezoid, two of the sides in this trapezoid have to be parallel. For example, I can draw something like this, and these two sides are parallel. And just a refresher here, when I say something is parallel, the symbol I use is drawing little arrows here. So that means these two lines are parallel. So I can draw a few more examples of trapezoids. One that looks like this. All right, so as long as the trapezoid has one set or two parallel lines as sides, then it is a trapezoid. So that's basically the only thing that qualifies a trapezoid for what it is. And we have one really unique attribute of a trapezoid that we need to consider. Let me draw out a random trapezoid here. As you can see, I'm going to label these as parallel sides. And we have the angles A, B, C, and D. And the unique thing about trapezoids is that angle A is supplementary to angle B. Angle C is supplementary to angle D. All right. So it's these two angles and these two angles that are in pairs of supplementary angles. So A is supplementary to B, C is supplementary to D. For any trapezoid, this is how it works. All right. But you have to be careful. These two angles are connected by a side that's not one of the parallel sides. For example, B and C are not supplementary, okay? Only A and B are, and only C and D are, okay? So that's something you guys should remember. So maybe take these notes in a notebook. So what a trapezoid is, one pair of parallel sides, which means two of the sides are parallel. And what we have is that A and B, those angles are supplementary. C and D, those angles are supplementary. Okay? And you may be asking, how do I find the area of a trapezoid? What's the area formula for that? What it is if we call the parallel sides as B1 and B2, so we call these bases actually. The parallel sides in the trapezoid, we call them the bases of the trapezoid. And these two sides, we call them the legs, just like an isosceles triangle. So the formula for the area of this trapezoid is the first base plus the second base divided by 2, all of that times the height, right here. So this is the area of a trapezoid. This is the formula. The first base plus the second base divided by 2, all multiplied by the height. All right.
Wait 1 sec. Let me take this down.
All right. So I'll wait a moment for you guys to write that down. If you study a little bit about averages, as you can see here, this is the average of the top and bottom bases. We take the average of those and we multiply that by the height. All right. So that's the area of a trapezoid. Are there any questions? Alrighty. So let's do some problems with trapezoids. So 5 minutes for these. And once you get your answer, please chat that to me and let you know if you're right or not. Now, when you tell me your answer, please refer to what problem you're answering. So if you're answering problem 1, say 1 dot and then your answer. So the last problem is kind of like a challenge problem. So if you have trouble with that, that's totally fine. Two more minutes. All right, so I'm going to go over these problems now. So the first problem says, what's the area of a trapezoid with parallel sides of length 4 and 6 with a height of 5? Well, the parallel sides, we call them the bases. And in the formula, the area is given by first base plus the second base by 2 times the height. So what we just do is we take the first base, 4, add it to 6, divide by 2, multiply by 5. We're going to get 25 in the end. So that's the area of the trapezoid. All right, just a direct application of the formula. So now, what are the measures of the angles in the diagram? We use the fact that if we have a trapezoid like this, A, B, C, D, A is supplementary to B, C is supplementary to D. So for this angle, this is 180 minus 86. For this angle, it's 180 minus 30. So, minus 150, sorry. And then the angle would be 30. And on top here, we have 94. So the angles are 94 and 30. Now for the last problem, how do we find the area of the trapezoid? Well, the area is given by the first base plus the second base, divided by 2, multiplied by height. So right now, what are we given in this problem? Just one of the bases, which is 20. We need to figure out what the other base is, along with what the height is. So how do we do this? Well, if we look here, we have a hint here, 120. What does that tell us? Whenever we see the number 120, it makes us think of the number 60. And 60 makes us think of a 30, 60, 90 right triangle. So using the property of the angles in the trapezoid, we know that this angle is 180 minus 120, 60. Ooh, 60-degree angle. That tells us that we're going to try to look for a 30, 60, 90 right triangle. But it doesn't look like we have one here right now. So what we can actually do is we can draw a triangle in. Right? I can draw this line here that makes a triangle. So what do we have here? We have a 30, 60, 90 triangle. Side length 6. Okay, so this length is 3. This length is 3 times the square root of 3. So what this is going to be, 3. The height, 3 times square root of 3. So now we have the height. We did it. So now there's only one step left to do. I want to find the other base, which is up here. How do we find that? Well, there's another hint here, 5 root 3. Well, the problem's already given us a right triangle. And the height is 3 root 3, so this side is 3 root 3. I see 3, I see 5. I think 3, 4, 5, right triangle, a Pythagorean triple. So one of the sides is 3 root 3, 5 root 3. The last side is 4 root 3. Oh, so now what do we have? This length is 4 root 3. As you can see here, what we have is now this length, the other base, is the same length as this down here. So if we subtract 3 and 4 root 3 from 20, we'll get the last base. So we'll do 20 minus 3 minus 4 root 3 to get the last base, which is 17 minus 4 root 3. So we have this base, we have the height as 3 root 3, and we have the last base as 20. And then if we plug these in, we'll get our answer. All right? So that's how you would do that. I'm not going to do that right now because that's quite a bit of calculations. Okay, any questions? Alrighty. Now we're going to go down the family tree. Next one we have up is the isosceles trapezoid, and it's this guy right here. What is an isosceles trapezoid? Well, if you think of isosceles, you think of an isosceles triangle. And an isosceles triangle, 2 sides are the same length. And that's the same exact thing with an isosceles trapezoid. The sides that are not parallel are going to be congruent. So that's what defines an isosceles trapezoid. The non-parallel sides are going to be congruent. All right? And a special attribute we have for an isosceles trapezoid is that the diagonals of an isosceles trapezoid are congruent. So just to refresh on what the diagonals are, this is a diagonal, this is a diagonal. And the diagonals in any isosceles trapezoid are congruent. Okay. Another thing we have about isosceles trapezoids is that the bottom two angles are congruent. The top two angles are congruent. So if we have A, B, C, and D, B is congruent to C. A is congruent to D. All right. And these are just the characteristics special to the isosceles trapezoid. Not only does it have these characteristics, but remember, as in the family tree, any quadrilateral below has all the characteristics of the quadrilaterals above it. So the isosceles trapezoid also has all the attributes that a trapezoid has. All right. So it has these special characteristics along with the characteristics of a trapezoid. All right. So that's what an isosceles trapezoid is. Any questions? All right. So we have two problems here about isosceles trapezoids. Take 3 minutes to do these. Once you get your answer, please chat that to me, and I'll let you know if you're right or not. So to make it easier on you, how about for the first problem, just list your answers in the order of A, B, and C. So the first number you put in is A, the second number is B, the last number will be C.
Wait, so B, C, C, D, and CA are segments?
Oh, sorry, for the second problem, I don't think there's a number in there. Let's just say the side length is 2 for BC. Sorry about that.
Okay, so CD is also 2.
All right, one more minute. All right, so I'm going to go over these problems now. So for the first one, we want to find the measures of angles A, B, and C. Well, first of all, we can use the fact that for any isosceles trapezoid, the bottom two angles are congruent, the top two angles are congruent. So 60 and C are both bottom angles, so they're going to be congruent. So you know what C is. C is 60. Okay? So now how do we find A? Well, an isosceles trapezoid is still a trapezoid. So A and 60 are going to be supplementary. So A is 120. Now we'll use the final fact that since the top angles are also congruent, then A is congruent to B, so 120 for B as well. So 120, 120, and 60. All right. For the second one, ABCD is an isosceles trapezoid. If BC equals CD, what's the length of CA? All right, so what does this say? BC equals CD. That's the first hint we see. So let's just label stuff. BC is 2, so CD is also 2. Since this is an isosceles trapezoid, well, BA is also going to be 2 because the legs of the trapezoid are congruent. All right, so now what? Well, we see 120 once again. That begs for us to use a 30, 60, 90 triangle. So let's first draw in CA. What does that look like? Well, ABC, this triangle, is an isosceles triangle. 2 right here, 2 right here, right? And then CA is down here. So what's the angle right here? Well, since it's an isosceles trapezoid, the top angles are congruent. So this is 120, and this is also 120. So this is an isosceles trapezoid. Now what? Well, let's use the the really important problem-solving technique we have with isosceles trapezoids, where we take the vertice, take it down, and we make it perpendicular. What does that do? Well, that splits the angle of 120 in half. We have a 60 here and a 60 here now. Well, 60 and its right triangle, 30, 60, 90 triangles. They're always going to come back. All right, 30, 60, 90 triangles are probably the most useful triangle you'll ever use in math. So once again, since it's a 30, 60, 90 triangle with 2 here, then 1 here, and then square root 3. So this length is square root 3. This length is also square root 3. So in total, CA is square root 3 plus square root 3 to square root 3. Okay? So are there any questions about that? So for these problems, you just have to, whenever you see the number 120, or whenever you see the number 150, or even 60, you're going to try to look for a 30, 60, 90 triangle that's going to help you solve your problem. Okay, so that's a really important problem-solving technique. Now, let's go further down the family tree. Our next up on the list is the parallelogram. The parallelogram is right here, and it's like the sibling of the isosceles trapezoid, right? The trapezoid had 2 kids, the isosceles trapezoid and the parallelogram. So the parallelogram is right here. And what a parallelogram is that a parallelogram has 2 pairs of parallel sides. So it looks kind of like this. These 2 sides are parallel. These 2 sides are parallel. Okay? So we have a lot of unique characteristics of parallelograms. Okay? So first of all, the opposite sides are congruent. That means this side is congruent to this side. This side is congruent to this side. Always in any parallelogram, the opposite sides are congruent. Opposite angles are also congruent. This guy is congruent to this guy. This guy is congruent to this guy. Okay, the opposite angles are also congruent. Okay, we also have adjacent angles, supplementary. I'll label that as SUPP. So adjacent angles are supplementary, meaning this angle is supplementary to this angle, and this angle is supplementary to this angle. All right. So any adjacent angles in a parallelogram are supplementary. meaning they add to 180 degrees. Okay? We have one last characteristic, is that the diagonals bisect each other. What do I mean by diagonals bisect each other? Well, if you know what bisect means basically means to cut in half. So we have two diagonals here. The diagonals cut each other in half. So this diagonal, if we draw them like this, the first diagonal is split into two halves. The other diagonal is also split into two halves, and those halves are congruent. So the diagonals will bisect each other, meaning they split each other in half. Okay, so that's the last attribute of a parallelogram. So these are all unique attributes for a parallelogram. And personally, I wouldn't recommend just writing this down. But if you were to look at any parallelogram, it's pretty easy to visualize, right? As you can see in this one, the opposite angles are clearly going to be congruent. And opposite sides, same thing. So I think it's more like it's better to visualize a parallelogram and visualize how these things work instead of just writing them down as words. Because I think in geometry, it's always easier to have a diagram in your head than just these words. Okay? So I'll give you guys a moment to write these down. All right, and you also may be asking, how do I find the area of a parallelogram? Well, it's just like a rectangle. It's base times height. If we take any base and we multiply by the height, we'll get the area of the parallelogram. But be very careful that if we choose this as the base, the height is not this side. It's not the other side. Because whenever we talk about bases and heights in geometry, the height has to always be perpendicular to the base. So what that means is that the height is actually like this. Okay? It is not the other side, because the other side is slanted a little bit. It's not going to be perpendicular. So the height, we always have to take a perpendicular length to the base. It cannot be anything else. Okay? So base times height, just like a rectangle. Except that now you have to make sure that you're choosing the right length for your height. Any questions? So those are all attributes of parallelograms. Let's go on to these two problems here. How about 3 minutes to do these? And let me know your answer in the chat. So for the second problem, just like the other problem we did a while back, when you tell me your answers, put the first number as A, second number as B, third number as C. for one more minute. All right, so most of you have done a pretty good job of answering these questions. So first problem is find the area of the parallelogram. And what a lot of people did is they did 13 times 10. But the side with length 13 is not perpendicular to the side length of 10. For any base and any height, in geometry, we have to have the base perpendicular to the height. All right, so it's going to have to be this length right here. So how do we find that? Well, we have a right triangle here. It says 13. So that reminds me of a 5, 12, 13 triple. So how do we make sure that this is a 5, 12, 13 triangle? Well, this side is 10. So opposite sides in the parallelogram are congruent. So this side is also 10. This side is 5, so inside we have a 5 right there. So 13 and 5, the last side is 12. And 12 is perpendicular to the side length of 10, so we just do 12 times 10, 120. Okay, so you have to make sure that you're taking the side that's perpendicular to the base, not just any other side. Okay, next one, find the missing angles. Well, first of all, we can use the fact that opposite angles in a parallelogram are congruent. 100 is here, B is congruent to 100, B is 100. What about A? Well, adjacent angles in a parallelogram are supplementary, okay? So A is supplementary to 100, A is just 180 minus 180. Similarly, A and C are opposite angles, so C is congruent to A, also 80 degrees. Okay? So A, B, and C, 80, 180. I think most of you guys did a pretty good job on these. So we have one last problem about parallelograms here. This is very, very similar to a lot of the problems we've been doing with triangles. So with just one little extra step. So how about 2 minutes for this one problem? So you guys have seen this kind of problem a lot. We've done this like probably a million times throughout the quizzes and the homework and the classes. So I think you guys should be pretty good with this one. So far, one person's gotten it. All right, so only 2 people have gotten it so far, Gavin and Melanie. So let me show you guys the solution. So first of all, ABCD is a parallelogram, find AC. Well, AC is right here. So what do we know about the diagonals of a parallelogram? Well, we know that the diagonals of a parallelogram bisect each other, meaning that they cut each other in half. So what this means is that this length right here is 1/2 of AC. And we have a lot going on in this triangle right here. So somehow we're going to use this triangle to find what this length is. And then we can find what AC is. Okay, so let's just take this triangle out a bit to clear things out. So we have a 6, a 3, and a 2, and we have x. So we've done this a lot. So we basically have 2 ways to find the area of this triangle. Base times height divided by 2. We can take any combination of base and height. So if we take 6 as the base, then 3 is the height. So the area of this triangle is 6 times 3 divided by 2. Another way we can find the area is taking a different combination of bases and heights. If we take x as the base, then 2 will be the height. So x times 2 divided by 2 is also the area. X times 2 over 2 equals 6 times 3 over 2. X equals 6 times 3 over 2. X equals 9. So this equals 9. X equals 9. So to get to AC, we know that x is 1/2 of AC. So AC in total is 18. Okay. So you see this triangle here. We've done this kind of problem a lot. You just have this extra step with the parallelogram. Now we've got the rectangle. The rectangle is next on the line. It's like the child of the parallelogram and the isosceles trapezoid. All right, and the rectangle has all the characteristics of a parallelogram, all the characteristics of a trapezoid, and all the characteristics of an isosceles trapezoid as well. And the only really new thing about a rectangle is it has 4 right angles. And since we've done a lot of problems with the rectangles already, I don't have problems for the rectangle today. So yep. So now we go straight on to the next shape we have on the line, a kite. So we started with the trapezoid on this side. So the granddaddy quadrilateral had 2 kids. One of them was the kite, one of them was the trapezoid. And we're going to go on this side of the family tree now. That's the kite. So what a kite is that adjacent sides are congruent. If I draw out a kite here, these 2 sides are congruent. These 2 sides are congruent. So the sides that are next to each other are congruent. And you know that this is a kite because it looks like a kite, right? It just looks like one, okay? So what makes a kite? A kite is that the adjacent sides are congruent. And a special thing about kites is that the opposite angles here, A and B, A is congruent to B. But only these 2 angles are definitely congruent. These 2 angles have to be the angles where different lengths of sides meet. Like this length and this length meet, they make A. So we can only have A and B congruent if they're the angles that are created by 2 sides of different length. So for example, if I had C and D here, C is not necessarily going to be congruent to D. It's not necessarily going to have anything in relationship to D. Okay? So only A is congruent to B. We have one last thing about kites. Is that the diagonals of a kite, if you draw them out like this, they are perpendicular. Diagonals, perpendicular. Perpendicular. Okay? So the diagonals in a kite are perpendicular. So a refresher on what kites are: the adjacent sides are congruent, the diagonals are perpendicular, and these 2 opposite angles are congruent. And you may ask, how do I find the area of a kite? Well, the area of a kite is determined by its diagonals. If we say the first diagonal as D1, second diagonal as D2, then the area is D1 times D2 divided by 2, the area of a kite. It's the first diagonal multiplied by the second diagonal divided by 2. All right. There's not really an efficient way to solve for the area using the sides. It's just with the diagonals. Okay. So I'll give you guys a moment to write those down. Alrighty. So let's go on to these two problems about kites. 3 minutes for these two problems. And chat me when you get your answer. For the second problem, we have 120 again. What does that tell you? I've said this a lot. Whenever you see the number 120, think about 30, 60, 90 right triangles. One more minute. All right, I'm going to go ahead and explain these now. So the diagonals of a kite have lengths 3 and 6. What's the area? Well, as we know, the formula for the area of a kite is the first diagonal times the second diagonal divided by 2. What that's going to be is 3 times 6 divided by 2. 9. Okay? So we just used the formula for that one. So now the area of the second kite is 9 times the square root of 3. BD has a length 6. What's the length of AB? Well, the area is 9 root 3, and we have a diagonal length. So what that tells us is we can use the area formula to figure out what the other diagonal is, because that might help us find what AB is. Right? So we're going to be able to find AC with the area formula. D1 times D2 over 2 equals 9 root 3. 6 times AC over 2 equals 9 root 3. So D equals 3 root 3. So AC is 3 times the square root of 3. Oh, look here, 120. What does that make me think of? 30, 60, 90 right triangles. And since what we know about kites is that AB is congruent to BC, so we have an isosceles triangle. an isosceles triangle. When 20 here, 3 root 3. These two are congruent. So we're always going to use our handy dandy isosceles triangle technique. Split it in half. 60 here, 60 here. So this is going to split 3 root 3 in half. 3 over 2 times square root 3. So that means that this side here, this length here, is just 3 over 2. This length is double that, 3. 3 is AB, so the answer is 3. And I see Gavin got that correct. All right. So once again, if you see the number 120, always think about 30, 60, 90 right triangles. All right. Just a handy dandy tip right there. So now we have the rhombus. The rhombus is the combination of a kite and a parallelogram. It's right here. This is a rhombus. Okay, it has all the characteristics of a kite, has all the characteristics of a parallelogram, and a trapezoid. It has all of the characteristics of the quadrilaterals above it. All right, so it's like a kite and a parallelogram had a kid. So what's new about a rhombus is that all 4 of its sides are congruent. Draw a rhombus like this. All 4 of its sides are the same length. All right, so that's really the only new thing about rhombuses. So since a rhombus is both a kite and a parallelogram, there are 2 ways we can find the area of a rhombus. First of all, we can use the diagonals way with a kite. We can multiply the diagonals and divide by 2. Or we can use the parallelogram way, where we put it on its side like this. We get the base times the height. Okay? So since a rhombus is both a parallelogram and a kite, we can use 2 different methods to find its area. Okay. Are there any questions? So to recap, the only new thing about a rhombus is that 4 sides are all congruent. 2 problems here. Take, once again, 3 minutes to do these. And I'll let you know if you're right or not. So my hint for the first one, try to use the parallelogram method to find the area of the rhombus, since it's a parallelogram. One more minute. All right, so I'm going to go over this problem now. So what's the area of the rhombus? What I would do is I would use the parallelogram method. So let's first rotate the rhombus so that it looks more like a parallelogram. So we have 2, 2, 2, 2, and 60. Oh, I see the number 60. What does that tell me? 30, 60, 90, right triangle. Okay, let's make a right triangle like this. Oh, conveniently, it's going to be the height of the rhombus. So we have a 30, 60, 90 triangle right here. This length is 1. This length is square root 3. So the height is square root 3. The base is 2. The answer is 2 times the square root of 3. Okay? So the next one, the perimeter of a rhombus is 52. If its longer diagonal is 24 units, what is the length of the shorter diagonal? Well, let's draw a rhombus like this. The perimeter is 52, which means that each side is 13, because 52 divided by 4 is 13. Okay? So its longer diagonal is 24 units long. This guy is 24. So what does that tell us? Well, let's draw in the other diagonal. We want to find out what that is. That's 12. Now what? Well, a rhombus is a kite as well. So that means these two diagonals are perpendicular because a rhombus is a kite. And the rhombus is also a parallelogram, which means that the diagonals will bisect each other, meaning the longer diagonal has been split in half, 12 and 12. I see 13. I see 12. What does that remind me of? 5, 12, 13, Pythagorean triple. We have a right triangle right here. 5, 5. So the entire length of the short diagonal is 5 plus 5, 10. So the answer is 10. Okay? So a rhombus has both the characteristics of a kite and a parallelogram. And that helps us in problem solving. Okay? So we've come to the end of the line. We filled out the entire grid, and we're down to the last item, the square. The square is the combination of all the quadrilaterals in the entire grid. The square is a kite, the square is a rhombus, the square is a parallelogram, the square is a trapezoid, it's an isosceles trapezoid, it's a rectangle, it's all of those things. Okay? And a square, we all know what a square is, so I'm not going to go in that detail about it. Okay, so a square is basically the most specific quadrilateral you can possibly get to. All right, so skip this slide for now. So we have the complete quadrilateral family tree. So you guys could take a screenshot of this right now if you want to, or later in the email, I'm going to post a higher resolution photo inside the email later. So you can either take a screenshot of this now if you want to, or you can wait for later and I'll send it through the email. Okay? So this is the complete quadrilateral family tree. So maybe before your test on quadrilaterals later on in life, you could review this chart. It's full of stuff that'll be really helpful to you. Okay? So that out of the way, let's go on to the quizzes. All right. So let's put the quizzes up here. Quizzes is now here. Stay live. Get ready for the quizzes. Let me see. Look at these. All right. I'll send in the direct code. Let me copy this. So I'm going to send the direct link in the chat. There it is. Or you can go to joinmyquiz.com. And the code is 562124. So the questions on the quizzes require a bit of thinking. And so I've made a lot of them with a time limit of 2 minutes. 2 minutes is a lot of time for you to think and to consider your answers. So when you look at a problem and you think it's hard, don't worry because you have a lot of time to work on them. Okay? And for this quizzes, if you come in later after I start the game, then I'm not going to be able to count your score in the final leaderboard. So if you join in the game later on, I'm not going to be able to count your score. Okay, so you have to join in right now, or else you won't be able to participate. Well, you will, but I won't be able to take your score on the leaderboard. Is anyone having trouble getting in?
No, I'm fine.
Okay.
I'm taking a very long time to get in because my iPad doesn't have very good internet.
Okay, so if anyone else has any problems, please let me know, and I'll wait a little longer to start the game. Maybe I'll share my computer sound. I'll wait one more minute for you guys to come in. So just like with any other quizzes, no calculator allowed, and don't rush on these problems. You can take your time. They're giving you guys quite a lot of time to work on these. And so you want to prioritize getting the problem right versus just taking your best guess at it. All right, starting the game in 10 seconds. 3, 2, 1, 0. All right, good luck, guys. This face thingy is now on the leaderboard. Andrew also. So once again, guys, take your time. You have a lot of time to do these problems, so better to take a lot of time to get it right versus getting it wrong. the problems right. The period now with a streak of 4 correct answers. Now in second place. Serena has moved to 4th place. The period is now in 1st place. Period now with a streak of 7 correct answers. So if you finish and you would like to leave, feel free to do so. Or if you want to stick around and see who comes out on top. Right now it seems like the period is going to get 1st place, unless one of the people down below are gonna beat him or her to it. Alright, so before you guys leave, there will be no class next week since it is the 4th of July. So enjoy your holiday, and then we'll resume class after the 4th of July, and that will be our last class together actually for the course. So on July 4th, no class. So our next class will be July 11th. Melanie has moved into 5th place. 6th. As soon as I get this point, we're waiting on Jonathan and see if he can get up in the leaderboard.
Anyway, the trivia was.
Jonathan now in 5th place. Jonathan in 2nd place now. Alright, seems like most people have finished. So let me type in the final standings. First place is Ryan. Pink. He's the period. 2nd place, we have a tie. Serena and Jonathan in a tie. 3rd place, we have Melanie. 4th place, Andrew. Or Andrew. And in 5th place, we have Kai. Alright, so I'm going to end the quizzes now. So, thank you guys for coming to class. So, I'll see you guys later, which will be July 11th. So no class next week. Enjoy your vacation, guys. Bye.